Next problem. If x of t is a band limited process such that sxx of omega which is equal to 0, where modulus omega greater than sigma, prove that 2 into rxx of 0 minus rxx of tau is less than or equal to sigma square tau square rxx of 0. So given sxx of omega which is equal to 0, where mod omega greater than sigma. This is same as sxx of omega not equal to 0, where modulus omega less than or equal to sigma. Both are the same. The meaning is same. So sxx of omega equal to 0, where which part mod omega greater than sigma. So other than that, it is not equal to 0. That is what we have written. Sxx of omega not equal to 0, where modulus omega less than or equal to sigma. Therefore, sxx of omega which is not equal to 0, where omega lies between minus sigma and plus sigma, 0 otherwise. We know that rxx of tau is equal to inverse Fourier transformation of sxx of omega. That is equal to 1 by 2 pi integral minus infinite to plus infinite sxx of omega e power I omega tau d tau is equal to 1 by 2 pi integral minus sigma to plus sigma sx of omega cos omega tau plus I sin omega tau d tau omega d omega, right? Here e power I omega tau is equal to cos omega tau plus I sin omega tau. That is equal to 1 by 2 pi integral minus sigma to plus sigma sx of omega cos omega tau d omega plus 1 by 2 pi integral minus sigma to plus sigma sx of omega I sin omega tau d tau. We are splitting into two integral. We know sxx of omega is an even function, cos omega is an even function. So first term even into even, an even function. So first integrand is an even function. We are applying property of definite integral. We will get 1 by 2 pi 2 times integral 0 to sigma sxx of omega cos omega tau d tau. The second integrand sxx of omega is an even function, sin omega is an odd function. Even into odd you will get odd function. So again we are using property of definite integral. We will get that the integral minus sigma to plus sigma sx of omega I sin omega tau d omega is equal to 0. So you will get 2 and 2 cancel. You will get 1 by pi integral 0 to sigma sxx of omega cos omega tau, right? That is equation number 2. Now put tau is equal to 0 into, so you will get rxx of 0 which is equal to 1 by pi integral 0 to sigma sxx of omega cos omega into 0 d omega. Cos 0 1, so you will get 1 by pi integral 0 to sigma sin xx of omega d omega. That is rxx of 0, right? That is equation number 3. Now rxx of 0 minus rxx of tau is equal to 1 by pi integral 0 to sigma sxx omega d omega minus 1 by pi integral 0 to sigma sxx of omega cos omega tau d omega. We are using equation 2 and 3 is equal to 1 by pi integral 0 to sigma. Grouping this one, sxx of omega is common, take it outside. First integrand 1, second one cos omega tau, 1 minus cos omega tau d omega. We know 1 minus cos 2a which is equal to 2 sin square a. Take a is equal to omega tau. Therefore, 2a is equal to omega tau. Therefore, a is equal to omega tau by 2. Replacing is equal to 1 by pi integral 0 to sigma sxx of omega 2 sin square omega tau by 2 into d omega. Therefore, rxx of 0 minus rxx of tau which is equal to 1 by pi integral 0 to sigma sxx of omega 2 sin square omega tau by 2 into d omega. That is equation number 4. We know sin x is less than or equal to x, trigonometric result. Therefore, sin square x is less than or equal to x square, right? Therefore, 2 sin square omega tau by 2 here we are having 2 sine square omega tau by 2, which is less than or equal to 2 into, instead of x you are having omega tau by 2, omega tau by 2 square. So squaring, you will get omega square tau square. Down you are having 4, 2 and 4 are get cancelled, you will get 2 by 2. So omega square tau square by 2, that is the equation number 5. Also omega is lies between minus sigma to plus sigma, that is omega is less than sigma. So omega square is less than sigma square. So omega square multiplying with tau square, omega square, so tau square less than sigma square tau square divided by 2 both side. So omega square tau square by 2 less than sigma square tau square by 2, equation number 6. So from 5 and 6 you will get 2 sine square omega tau by 2 less than or equal to omega square tau square by 2 less than sigma square tau square by 2, that is equation number 7. So comparing 4 and 7, Rxx of 0 minus Rxx of tau, which is equal to 1 by pi integral 0 to sigma s xx of omega 2 sine square omega tau by 2 into d omega, which is less than 1 by pi integral 0 to a sigma sine xx of omega sigma square tau square by 2 into d omega using 7. So that is, which is less than sigma square tau square by 2 1 by pi, because sigma square tau square by 2 is a constant with respect to omega. So we are taking it outside, integral 0 to a sxx of omega d omega, which is less than sigma square tau square by 2 Rxx of 0 by using 3. Third equation is both are equal, Rxx of 0 is equal to 1 by pi integral 0 to sigma sxx of omega. Therefore, we will get 2 into Rxx of 0 minus Rxx of tau less than or equal to sigma square tau square Rxx of 0. Right, thanks. We'll see in the next